Hello, everybody. So the video that we're recording now was supposed to be the week 11 lecture 2. However, I realized that I said week 11 lecture 2, the week 12 lecture 2. However, what I realized was that this lecture, the one labeled lecture 13 here, is actually designed for the week 3 material, which is why we're doing it now, week 13. So what's the point? The point is that this is the week 13 lecture 1 video, and there is no video here. Um, all right. With that said, we'll go ahead and jump in and look at these lecture slides. So I've already downloaded them. So lecture 13, methods 2, I've got them right here. And also we'll open up Zybooks and we'll look at the week 13. So week 12 here is all about methods. And we covered most of that in the previous lecture. And the week 13 it says like array parameters, scope of variables, overloading. That's what we're covering today. Um, just kind of some extra stuff you might want to be aware of if you're dealing with methods. Also, let's make sure we have Eclipse open. Do I see it? I do not, but it's probably there somewhere. Nope, but we're opening it now. Do. All right, cool. So let's go ahead and get started with our lecture slides. So the lecture slides are open somewhere. Why can I never see the preview app? Okay, let me make this a little bigger. Cool. So this is kind of more advanced topics in methods. So what are we going to be learning in this video? We're going to learn how Java deals with array parameters differently than primitive types like int and double. And that's within methods specifically. And we're also going to learn about the scope of variables and method names in Java. And we're going to learn what overloading is. It's a concept that's involved in Java, but also other programming languages like C++ as well. So it's a useful thing to understand, and we'll learn about it. With that said, let's go into our first topic, which is going to be array parameters. Okay. Now, there's a slide here that tries to explain everything, but before we do that, I want to show you something in Eclipse. So if I just need a kind of a blank assignment, or not assignment, but project here. So we'll just call this method arrays to make a project. We'll open that up. We'll make a class. I'll call it method arrays. Shake the little box. Okay, cool. So we have a blank project here. Now, what I'm going to do here is I'm going to create a variable and we'll just make it an integer. And I'm going to make it 9. Okay, just a value there. And then I'm going to call a method. Now, I haven't written the method yet, so I'm just going to call it my method X. And then I'm going to system.out.println X. So right now our code doesn't run because I haven't written this my method yet. So under the main method, I'll write it. So we'll say public static void. I called it my method. And it needs an integer to come in. It doesn't really matter what you call the integer. You don't have to call it X here. Call it num. And I go num equals, let's pick another number, 420. So when I run this code now, we're going to get 9 printed. Why do we get 9? Well, we made X equals 9, and then we put the X into my method. It comes into my method with the name num. We changed it to 420, and that's all it did. Then we come back up here and we tried to print out the X value and it was still 9. Okay. And the name here, num, doesn't matter. Like if I go and I change this to x so that it matches the x up here, that still doesn't affect anything. It's still going to be 9 because the x up here is a local variable to main, and the x in here is a local variable to my method, which means they're just different x's. Okay. And the point is that this method, which modifies x, right? X equals 420, um, does not actually affect the original x. Okay. And the reason for that is simple. Uh, my method receives a copy of the value in x. That's what it receives, a copy. So the original x is 9, and then a 9 gets put into my method, but the 9 is a copy. So if you make the copy 420, that's great, but it does not affect the original x value at all. Okay. And that's because my method receives a copy of the value in x. This is because int is what we call a passed by value. So we say that int is passed by value. All primitive types are. So all primitive types are passed by value. Okay. Now we want to see like almost the exact same thing, but with an array. So the closest we can do with an array is if we want to make an integer array, we have to put square brackets there to say that it's an array. We give it a name and we can type in an array here. Now I'm going to put in just one number. Um, I don't know, let's say 3. Okay. So this is an array with one thing in it. That's as close as we can get to a single number, and still have an array, right? Because the point is to have an array. And then I'm going to call another method. I'm going to call it my method 2. And we're going to put the y in there, which is an integer array. We have to specify that. And then when we're done, I want to print the y value. So system.out.println, and we'll print the y value, but specifically y0. Y0 is going to be 3. Um, all right. Now, I haven't written this method yet. So like if I comment this out and I run this, we get 9 and 3, right? So like the x value, x is plus x. Y is plus y0, right? So we have that the x is 9 and the y is 3. We should probably put some spaces in there. Run it again. X is 9, y is 3. Okay, but now I'm going to try to write the equivalent of this method, but I'm going to write it for an integer array parameter. So let's uncomment that and let's copy paste this whole function here. And if we wanted to make this work for an array, we would have to change the parameter here to have square brackets. And here we couldn't say x is 420. We'd have to say x subscript 0 is 420. And again, this variable here does not need to match the variable up here y, but if you want to, you could make it match like that. And also, I should call this my method 2 because I called it my method 2 up here. So these are trying to do basically the same thing. But when I run it now, I've got an error. Let's let the error happen. What's the error? Method is type method arrays are not applicable for the integer array y. Uh, oh, sorry. I don't know why I typed this here. Um, we need to say int square brackets here. We don't need to say int square brackets here. I do not know why I typed that up there. Sorry. Um, So this section of code here, we declared an X variable, we put the X into my method, and then we printed it out. And what we observed is in the comment that my method receives a copy of the value in X, and that's why it was not changed. So when we run this, the X value stays 9, doesn't change into 420. But when we do the same thing with an array parameter, the Y, where Y is 3, I put Y into my method 2. My method 2 tries to set Y0 to 420, and then we print it out, and we actually do get 420. So the Y value changed, right? So the X value was 9 at the beginning and at the end, but the Y value is 3 at the beginning and 420 at the end. Hmm, right? That's different. And so the reason it's different is because my method 2 receives the reference for uh, the array Y. Now, I'll explain that more in a minute. Uh, this is because arrays are reference types. I'll say passed by reference. Passed by reference. All objects and arrays are passed by reference. Okay, so the fact of the matter is, if you modify an integer in a method, it does not affect the original. It does not affect the original integer, right? So modifying an int in a method does not affect the original variable. But modifying an array in a method does affect the original variable. So setting x equal to 420 for an integer in a method does not do anything to the original variable. Setting an entry in an array to 420 in a method does affect the original array. Okay, that's it. That's the whole thing. And it's because of how they're passed. So integers are passed by value. The method receives a copy of the variable. Arrays are passed by reference. The method receives a reference, which is a memory location where the object is in memory. And so when you modify it, you're actually modifying the memory where the original variable is. Now, having said that, and we've seen it, we can come back here and read this and hopefully make some sense out of it. So in Java, arrays are objects. Their references are passed. This word by value is true, but it's kind of misleading, right? It's the word there is references is what you want. The reference to the array parameter allows the method to access and modify the original array. What does it mean? This is the key. It means if you pass an integer x into a method and change x, the original x from main does not change. If you pass an array of integers into a method and modify the values, the original y from main will be modified. Okay? We just need to understand that. That is what we're dealing with here. So this is just an example of that. So like you can look here and see this method called modify array, and it says ARR0 equals 10. So that would be changing the first entry to 10, right? And if we try to print the array before the modification, and then we run modify array, and then we print out the array again, maybe we could even just copy this. I don't know if it'll copy paste from a PDF properly. It did. So if I put the whole thing here and we run it, we also need, I just realized I misspelled method again. That's like the second time. So um, you could see that this is going to make an array, print out the array, modify the array, and then print out the array again. And you probably see this arrays dot toString my array. And if you don't know what that is, which you shouldn't, there's this import you can do, Java util arrays. And so this class has a lot of useful functions for arrays, including printing out an array. So we've been printing out arrays manually with like for loops, right? But if you're too lazy to do that, you can include Java or import Java util arrays, and then we can do arrays dot toString and then the name of your array, and it'll convert your array to a string. So then we can just print it out. So pretty convenient. Anyway, we can see that this method here, which sets the first entry of the array to 10, does in fact set the first entry of the array to 10. Okay, so when you pass an array into a method and modify it, you're modifying the original variable too. All right. Now, the next thing we want to talk about is scope just a little bit. Um, so scope defines the visibility and accessibility of variables and methods definitions in Java, and the scope determines where the variable or method can be accessed. So there's just kind of a bunch of stuff here, and the next slide will go through and explain it all. But like this is just a class. So public class scope example. So there's this variable here, int instant variable equals 10. Now this variable here, it's inside of the class, right? But it's not inside the methods. So maybe this is just so I can type a little bit here. I'm going to type, do I have notes up? Cool. Where web browser? No, where's preview? Now where's notes? Okay. Um, so this variable that's called instance variable, oh, I hate that, is visible or is defined inside the class. All of the functions or methods in the class can access that variable, which is instance variable. Okay. So all the other methods can see it. So instance variable, like here where we try to print it inside a main, inside the method instance variable, that works fine. You can see it there. And in this method main, if we tried to print it out here, that would also work. So instance variable is going to be visible in both of these methods because it's at the same level as them. So instance variables inside the class, and so are these two methods. So they can all see this variable. Okay. Now, if we go inside of a method, though, like in example method, there's a variable called local var, right? Uh, it is defined inside of the example method. Okay. So we can read that variable or access it. I'll say we can access local var inside of example method. We cannot access local var in main method because it's defined inside of a particular method. So it's only available inside of that method. You can think of the curly braces as being kind of the boundaries. So like this variable, instance variable, is inside of what set of curly braces? The curly braces up here that start the class and the curly braces at the very end that end the class. So in this entire section of the class, the instance variable is visible. However, in local var in terms of what curly braces is it defined within, is defined within this set of curly braces, the one that starts example method and the one that ends example method. So within this section of code, that's where local var exists. Okay, so local var is only visible in the method, but it is visible in the method. So if you come down here to this method, this is not where local var lives, so it's not accessible in here. All right. Now, there's also a variable called block var. Block var is defined in, where is it? It's actually defined just in this if statement, right? Block var is defined in an if statement, right? That's where its curly braces are. It's inside of this curly brace and this curly brace. So only this little section of code is where the block var is defined. So defined in an if statement. So inside of the if statement, it is accessible outside of that if statement. Block var does not exist. Only inside the little section of code where it's defined. Okay? So that's the whole idea. So if you define a variable inside of like an if statement or a for loop, it only exists in the if statement or a for loop. If you define a variable like local var inside of a class, then it's only available inside of that. I said inside of a class. If you define a local variable inside of a method, it's only very available inside of that method. Um, if you define a variable like instance variable inside of a class, then it's available in the entire class, right? So we have to think about where we put our variables to make sure they're visible where we want them to be visible. So if you want like local var to be available in multiple classes, then you don't put it inside, or sorry, multiple, geez, I'm saying everything wrong. If you want local var to be available to multiple methods, then you can't define it here. If you wanted it to be available in example method and in main, you would have to move it outside um, of the method and put it in the class. So you have to think about that a little bit. So like sometimes what you'll see is like if I had some important constant, right? I could do like final int, um, like I'm gonna define pi, right? And I go 3.14, right? Something like that. It won't let me do that because I need to say that it's public and static, probably. You won't let me do that either? How about that? No? What are you complaining about? Oh, it was complaining about the fact that I said it was an int the whole time. Oops. Um, so we probably didn't have to do all that, but um, like I can make a final double and call it pi. And right, our code runs here. And if you wanted to, like in the modify array method, right, if I do system dot out dot println pi is plus pi. Oops, what happened there? Plus pi, right? If I do that there, what? Cannot make a static reference to the non-static field of pi. Okay, so we did need actually public static final double. What are you complaining about now? Print. Oh, I misspelled print line. Okay, fair enough. Method print line. Oh, I still misspelled the print line. Okay. Oh, okay. There we go. So the point is that this variable that I defined in my method, I can access it from modify array. And if I remove it from there and I put that into main, that also works. So you can, any variables that you need access to in multiple methods, get defined inside of the class, but outside of the method. Cool. So that's what we're talking about when we're talking about scope. So this just summarizes what we just did about where the variables are visible. So I'm not going to do that again, but we can read it. Um, all right. So last topic here. The last topic is method name overloading, which, I mean, sometimes they're just going to call it overloading. The name is overloaded. There's other things that can be overloaded, especially in other programming languages, like plus can be overloaded. Actually, you can see that plus is overloaded right here, right? Plus means adding, right? 3 plus 4 equals 7. So how can you add a string, right? That doesn't make sense. But somewhere in Java, they must have defined plus between two strings to mean that we were putting the strings together, right? We were adding the strings together. Somebody wrote that. So that would have been what they call overloading the plus operator. That's not what we're talking about here, though. So let's not do that. Let me start with a blank method again. A blank main. Okay. So here's just a blank project, and I'm going to call a method. So I'm going to say um, print number. Okay. And I'm going to put a number here. Specifically, I'm going to make an integer x, and it's going to be 7. And I'm going to have a double. I'm going to call it y, and it's going to be 13 point bunch of stuff. Okay, so I got two numbers. And then I want to call print number x. Okay, now we have not written print number, right? So we can't do this yet. Let's put it, I guess, below. So if I want to write a method that just prints the number, I can go public static void print number. And right now x is an int, so let's do it int. Let's just call it a. And I'm just going to do system.out.println, and I'm going to say number is a. Cool. Now this should work fine, right? I'm going to print my number, and it says number is 7. But what if I want to print y, right? So I come down here and I go print number y. And if I try to run this, it's not going to work, right? Because it's going to tell us unresolved compilation problem, the method print number int, right? Print number int in the type method arrays is not applicable for the arguments double. So it's telling us you can't put a double in place of an int, right? You can't put a double where an int goes. That's what it's saying. Okay. Now, the way that we resolved this, actually, if you think back to the earlier method that we wrote, was you could copy this entire method, right? And you go, okay, let's just do this. Let's change this int to a double, and we'll call it print number 2. And that's probably enough. Have to go up here and change this to 2. And then we can print out both of them, right? So now I can print 7 and I can print the 13 point whatever. So I have two different methods. But if you think about it, isn't it kind of annoying that I had to name them different things? And guess what? You don't have to name them different things. You could write the method once to work for integers. You could write it again to work for doubles, and you can just name them the same thing. So print number for ints and print number for doubles. And guess what? Well, it doesn't work because I kept the 2 up there. But there we go. Number is 7. Number is 13.182.357. So what's happening here? Well, I wrote 2 methods with the same name, print number and print number. But the first one is print number for an int, and the second one is print number for a double. And so Java can tell the difference between them. And when you put in print number X, and X is an int, it's going to run the one for ints. And when you run print number Y and Y is a double, it's going to run the one for the double, right? You could do as many of these as you want. You can go public, static, void, print number, string A, system.out.println. Number is, I guess we could just keep using the same code. We could do print number 7, write it in words. What I do wrong? Void. I wrote void with an E. It's the European spelling. It's not. What I misspell now? Oh, print LNT. Jeez. Cool. Right? Number is 7, number is 13.18, number is 7, right? So you can write multiple methods that all have the same name as long as the parameters are all different. You can't have the same parameter list. So let's go back to preview here. Method overloading allows defining multiple methods with the same name, but different parameters. The compiler determines which method to call based on the method's signature, the name and the parameters. So for example, you could have call two methods with these signatures, one using int and one double. This is exactly what we just did, right? So we did print num int x, print num double x. So if you put in an int, you run the top one. If you put in a double, you run the bottom one. But you could not have two print nums with exactly the same type of parameters because the compiler would not know which one to run. Yeah. So like it's perfectly fine to have all three of these, but you can't just like take one of these and have two print numbers that are ints, right? Like let's say I'll change that to C and I'll change that to C. This you can't do. You can see it's highlighted them with an error because now how does it know which one to run when you put in an int? It actually it was running the old one, but so like this right here, it says duplicate method, print number int. This will say the same thing. Should uh, and it'll tell us to rename it. So you can't have two methods with the same name and the same parameter list, right? Int. So that's why you get the little error on the left. Take it away and everything's fine. So that's it. That's what method name overloading is. And so here's an example. And this method just is called display. So you can display a num and it says displaying an integer. You can do display a string and it says displaying a string. Display two integers. And now you could call them display 10. That's one integer parameter. Display hello. That's to display a string. Display 20, comma 30. That's for displaying two integers, right? So three different methods, but they all have the same name. So here it looks like there's actually, like, if you only look at main, you'd think, oh, there's one method called display. Well, no, there's actually three. There's three methods called display. They just all have the same name. Okay. This example, the display method is overloaded with three versions. The first version takes an integer, the second version takes a string, third version takes two integer parameters. So yeah, these are different too, right? One int is different than two ints. So as long as Java can tell the difference between the parameter lists, then everything is fine as far as Java is concerned. Depending on the argument passed during the method call, the compiler selects the appropriate method to execute based on the method signature. Note, method overloading is determined at compile time based on the number, the type, and the order of parameters. Yeah, so we didn't need to do it, but if I go here, right, if I were to write another one of these and I go two more of them, if I do int a double b, right, to print an int and then a double, that is different than if I had done double A, int B, right? So this one is int then double. This one is double then int. So those are still different. The compiler would be able to tell the difference between them, right? So I can go print number. If I go 3 comma 5.5, that is different than 3.37, right? Int double, double int. And just so you can see that they're different, right? If I go, I'll put 1 here and I'll put 2 here, just change the text that's printed. And you can see that we ran both of them, right? So int double, double int are different methods. And so you can see I didn't put any spaces between the numbers, by the way, so the numbers are printing dumb, but that's not the point. The point was the parameters. Cool. So what did we get from that? We get that the number of parameters, the types, int, double, etc., and order, right? Int, comma, double is different than double, comma, int. Summary. We learned how Java deals with array parameters, right? Specifically, you can modify an array inside of a method, and it modifies the original array. Second, we learned about scope and variable names. So if you declare a variable in a specific section of code, it's local to that section of code, and it's not available outside of that. And we learned about overloading, um, which is where we have multiple methods with the same name, but they operate on different parameter lists. Cool. All right, so that's going to be it for this lecture. So hopefully that was useful. That covers most of week 13, actually. So there's some stuff in here that we didn't cover that will happen in the next lecture video. All right, that's it for now. I'm going to hit stop recording.